So let's take a look at the homework, and then we'll look at some more string methods, and then start getting into classes. So we were to write three different methods: DisplayVals, RemoveVals, and reverse. Let's start with reverse. So we'll make this guy a static method. And so reverse is to return a string that is in the reverse of the original string. So our return type for this guy is going to be string. We'll call this guy reverse. He's going to take a string as a parameter. All right, so reverse will take a string as an input, do something, and then return a new string. Now, our job here is to reverse the original string. Now, strings are read-only entities. Therefore, we need to build a new string that is the original string in reverse. And kind of our go-to move for building up a new string is through the empty string. So we'll create a string called answer. Maybe start this guy off as the empty string. Now we need to walk our string in reverse, concatenating on to answer each character along the way. We actually could walk our string forward and concatenate on backwards if we wanted to, but let's write the loop that goes through our string in reverse. Okay, so this is going to be kind of our standard for loop, but instead of starting at bucket 0 at the beginning, we're going to start at the last legal bucket in our string. And what's the last legal bucket in S? What's the position of the last legal bucket in S? S.length minus 1. So we'll start a for loop for int I is equal to s.length minus 1. That's the last legal position in S. We're going to keep going as long as I is greater than or equal to 0. And we'll subtract 1 from I each time. So this will take I on a voyage between the last legal index in S to the first legal index in S. All right, and what will we do each time? We'll say answer is equal to whatever answer is currently equal to, concatenated with. Then we want to go ahead and grab the character that lives at a specific position in S. So we'll say s.char_at I. Now, char_at there, that's a method, right? What kind of method is it? Is it a class method or an instance method? And how do you know will be my follow-up question. We're seeing a method being called here. So we need to consider, how do the different kinds of methods get called? How do class methods get called? By the name of the class in which the method was defined. How do instance methods get called? Like this, using an instance of the class in which the method was defined. Okay, so how do we know that S is not the name of a class? Or how do we strongly suspect that S is not the name of a class? In this case, we know it's not the name of a class because we have it came in as a parameter. But what are some things that we can look at as evidence that S is likely not the name of a class? Class names typically start with a capital letter, typically, kind of a naming convention. Also, we see we have a variable here named S. So we defined S ourselves, and we realize that S is a variable of type string. So S would therefore be an instance of the string class because it has an is-a relationship with the string class. So we would identify this guy right there as being ultimately becoming an instance of the string class, and we are calling a method with that guy, therefore that method must be an instance method. If we were to go look at the definition of char_at, would we see static or would we not see static? So lively. No static. No static. Static is what we see for class methods. The omission of static, the absence of static, would be for instance methods. So if we look at the definition, we look at the documentation, we would not see static in front of the char@, method, which then tells us how do we call it. We call it using an instance of the class in which that method was defined. In this case, it's the string class. So we say s.char@I because we have a variable named s that happens to be an instance of the string class. All right, so this is going to give us the character that lives at position I inside of s. We're going to concatenate that onto answer, the current version of answer, and store the result back in answer. So this for loop is going to go through, and it's going to walk s backwards, taking each character from s and concatenating it onto the end of answer, which will build answer, which will build s in reverse. So when we're done with this for loop, answer should hold s in reverse, and we want to go ahead and return answer. So if we want to go ahead and test this, is this a class method or an instance method? Class method, how do you know? Because static. And how do we call class methods? Using the name of the class in which the method was defined. And what's the name of this class? Driver. So we'll say driver dot reverse. And we'll go ahead and pass in this string we created right here. So we'll pass in s. All right, so what will the output of this program be? Good, it's nothing. Why not? Because this guy boils down to whatever reverse returns, which is a string, and I'm not doing anything with it. So if I want to say string result is equal to that, and then go ahead and print out result, now I should get elephant in reverse, which I'm not going to try to pronounce. So there's elephant in reverse. All right, questions on that one? Go ahead.
I just sort of wrote, I'm like kind of like following along with you, and when I wrote return answer, I'm getting error with it.
Okay.
Could it be?
It's definitely because you didn't write exactly what I wrote.
I figured.
Make sure you have your variable answer defined before the for loop. And also make sure you have a return type of string.
And also make sure I is greater than or equal to 0, not less than or equal to 0. I made that mistake last night.
You probably have an infinite loop.
I might have something going on.
Yeah, so check this guy right here. That Boolean expression.
I've got that guy going. It's like all of my like print chars in reverse are also messed up.
Print chars in reverse are messed up.
Yeah.
Well, I'd have to take a look at it.
Yeah.
All right, so that's reverse. So now let's look at maybe display vals. Let's identify vals first and then look at how we can remove them. Okay. Let me quickly here. Oh, I had this problem last time, didn't I? Where it wasn't indexing Keynote. Didn't I have to do an update on Keynote last time? It's very... very nice of them. Their own application won't index. All right, so what methods did I introduce last time? What methods do we have access to from the string class? We have char@. What else? Did I show you any other methods from string? I didn't show you replace. Anything else I showed you in class? Did I show you IndexOf? Or not yet? Okay. Huh? I don't think I showed you value of. All right, so let's go and we'll write this just using char@. So let's do DisplayVals first. So we're displaying stuff instead of returning something. So my return type is going to be void. We'll call this guy DisplayVals. This guy will take in a string as a parameter, and you can name the string whatever you want. I'm just calling it S. All right, and we're going to go through our string, and we want to identify whether each character, well, whether the character we're currently looking at is a val. Okay, so we have to decide how we're going to identify vals. I'm probably going to go ahead and I'm going to write another method here, kind of a helper method that will help me identify vals for right now. So this guy's going to be a static Boolean isVal. This guy's going to take a char_c as a parameter, and it's going to tell me whether or not the value that was passed in is a val. All right, and we're going to go ahead and just create a super Boolean expression here. So we're going to return the result of C equivalent to A, or C equivalent to E, or C equivalent to I, or C equivalent to O, or C equivalent to U, or, and I'm going to steal all these, I'm going to do the uppercase version of each of those. So there's A, E, I, O, U, and I'm going to go ahead and just kick that down a line so it all fits on the same thing. Notice that Java doesn't care if it's on one line or not. So this guy will return true if the character I pass in is an A, or if it's an E, or if it's an I, or if it's an O, or if it's a U, or if it's the uppercase version of any of those guys. All right, and with the OR Boolean operator, it only takes one of those to be true for the whole thing to be true. So even though this is a big, long, scary Boolean expression, it ultimately boils down to a single value of true or false. And we're going to return that value. That make sense? So that's isVal. That just gives us a nice little helper function. So for displaying vals, we're going to go through our string. So it's going to be our standard for loop for going through a string. So for int I is equal to 0, I is less than s dot s dot length I plus plus. And then we want to ask a question here. We want to ask if the current character we're looking at is a val, let's print it. So I'm going to ask a question, if, and I have a tool that we just wrote up here called isVal. Is this guy a class method or an instance method? Class method. How do you know? Static. So how do we call class methods? Using the name of the class in which the method was defined. So driver up there. So we're going to say if driver dot isVal, and this guy expects me to pass him a character. What character am I going to give him? The current character we're looking at, which is the character that lives at position I in my string. S dot char@ I. If that's a true statement, if s dot char@ I is a val, then we want to print it. System.out.println s dot char@ I. That make sense? Let's go ahead and test that guy. So rather than calling reverse here, let's just go ahead and driver dot DisplayVals, we'll pass it S. So this should display just the vowels inside of elephant. So there's the vowels. And if I added, let's make this a capital A to make sure it detects capitals. There's that guy.
What is the benefit of putting driver dot in front of DisplayVals?
You mean because it's not required?
Yeah.
Well, the easiest benefit is this. If I say driver dot, it gives me a list of all these things. And then I say DisplayVals, and I can just press enter on it, so it spells it out for me. So that's the convenience for a human perspective. Technically, also, it's a higher performance. You know, it is the program's faster if I write it that way, because otherwise, if I say DisplayVals here, it's going to look at my local scope and say, do I have something called DisplayVals? If not, I need to go to the next scope up, and it's going to search in the scope associated with this guy, and that's where he will find DisplayVals. So it actually is faster anyways. So it's, you know, I guess double good. It's more convenience for us, and it's faster. I didn't initially start off by calling it this way because I didn't want to have to explain the concept yet. Make sense? Just we put static out front just because. Remember I mentioned that? But now we have some context for why we're putting static out front. So this is not required, but I would always put it there because it's not wrong as long as you're calling a static method. The real reason, if we talk about this syntactically, the reason why we're allowed to not put driver in front of there is because we are calling a static method from within a static context. Since I'm in another static method inside the same class that this other static method exists, I can directly reference it. But I will always write it this way. Not just for class to like emphasize, but I write it that way on my own as well. Okay, so that is DisplayVals. Any question about that one? It makes sense how we wrote a little helper function for ourselves here that we can conveniently call to test if something was a val. We certainly could have grabbed this code from here and just put our super Boolean expression in here. You know, if s.char at I is equal to A, or s.char at I is equal to E, or s.char at I is equal to I, blah, blah, blah. That would have been a pretty scary, an even scarier Boolean expression, and this line right here would have looked pretty ridiculous. So by shoving it into a nice function here, it makes this code read much better. All right, last one is to remove vals. So and this guy is what returns it? Returns a string with all vowels removed. So we are, again, not printing something, we're returning something. So my return type here will be string, called remove vowels. This guy will take in a string as a parameter. Now, because strings are read-only, we actually don't have the ability to remove vowels from a string using what I've taught you so far. There technically is this thing called string buffer that allows you to change individual elements. But, you know, we've been dealing with concatenation. We want to solve all the problems using all this stuff we've been introduced in class. There's a reason for that, because that builds up your problem solving. Okay, we're kind of pretending to be MacGyver. You know, we're stuck in a garage. We need to escape, and we have 4 things available to us, and that's how we need to solve our problems, is using those things that are currently laying in our toolbox. So really, the way we should read remove vowels is keep non-vowels. So we're going to build up a brand new string that is comprised of every character in the given string that we find that is not a vowel. All right, so we're going to have a string. Maybe we call this guy answer. We're going to go through every element of our string. So we're going to need our standard for loop. For int I is equal to 0, I is less than s dot length, I plus plus. each time through, we want to ask the question, am I looking at a val? Okay. The real question we want to ask is, am I not looking at a val? So if I am not driver.isVal s.char@I, if the guy I'm currently looking at is not one of those, that is to say, if isVal returns false for that. So what I have written here is the same thing as writing that. If driver.isVal is equivalent to false. So some of you might, maybe as a beginning programmer, you might prefer this syntax. It's a little bit clearer. But understand that that not operator inverts a Boolean. So if driver.isVal were to return a true, not that would say, is it a false? Is it true that it's a false? All right. So if driver.isVal s.char@I, if that guy's equivalent to false, then I want to keep it because that means it's not a val. So I'm going to say answer is equal to answer concatenated with s.char@I. When this for loop is done, I would have gone through all of the characters inside of S and kept all the non-vals inside of answer, ultimately returning answer. Now when I come up here to test this, we'll go ahead and say string result is equal to driver.remove vals. I'll go ahead and pass it S, and then we'll print out system.out.println result. So result should be elephant with all vowels removed, just the non-vowels still there. Make sense? All right, questions about any of those? All right, so let me give you this version of the code inside of Slack, and then we're going to upgrade this a little bit with some new functions. See if Slack is still indexed. It's not. All right, something has happened with the indexing of stuff in here. Is the oh, this reminded me. So if the next hackathon was the current hackathon, if you were following us on Slack, was pretty successful. I was a little bit disappointed that the teams didn't officially win. I really thought they were going to get first and second, to be honest. But I think they probably finished fourth and fifth is what we were kind of doing the math, how it worked out. One of the teams did get $100 in cash from one of the sponsors who walked by them while they were working and just said they really liked what they were doing and literally threw $100 down on the keyboard and walked away. So that was kind of a cool thing.
What did they make?
So the two teams, one of the teams made, this was in Unity, so both teams did virtual reality stuff. So they,
HoloLens or
No, HoloLens is AR. So yeah, so they did VR. So we had Rifts there, Oculus Rifts. So one of the teams made an entire model, like kind of think Super Mario Brothers 3 style of the University of Illinois campus, which is a big campus. So they split up the work between the four of them, and and he was on that team. So they did. I mean, they did a really cool job. So they did this. The whole campus was mapped out, and then the idea was wherever you are on campus, you can pick a destination. So if you've ever been to the University of Illinois or if you've been to Madison, similar type thing. These are big campuses with lots of buildings where you walk multiple blocks to get to your classes sometimes. So anywhere you are on campus, you could pick your destination, like you hold the hand control up in your hands and it gives a pop-up and gives you the list of possible destinations. So let's say you wanted to go to the basketball stadium at U of I, which is called the Assembly Hall. You click on that and it takes you shortest path walking through campus all the way to the basketball stadium. Instead of make it look like the Assembly Hall, we just put a giant basketball. I say they put a giant basketball. So then you knew that's where they play basketball, over by the giant basketball. So it was real. I mean, it was well done, and that's in 24 hours. They put that together. So that's what that team did. The other team did a thing that to benefit new students coming in. University of Illinois again has a zillion different dorms, and so there's kind of 50 unique dorm rooms, shapes and sizes. So what you would do is you would you pick the dorm you were assigned, you pick the type of room you're in, and then it would teleport you into that room. So you were physically standing in a room of the correct dimensions and layout for your dorm room. And then they had controls where you can like put a laptop somewhere, you could put a fridge somewhere, you kind of create your room and figure out whether stuff would fit and that kind of stuff. So that's what they did. And they did a really good job as well. So I was pretty impressed with both groups in terms of how much they got done, how they divided up the labor in the groups. So I think everybody, you learn stuff.
Yeah.
Yeah, so I think everybody learned quite a bit. So I'd really, really, really encourage people to take advantage of these hackathons. I think you probably learn more in 24 hours than you maybe learn in an entire semester in a lot of classes.
Is our fall one scheduled yet?
I don't think it's officially scheduled. I should know on Thursday the date for it. I know Professor Locklear, Josh Locklear, was picking a final date for it. I think it's sometime in November. I don't know which date. But I think we'll try to announce them as early as possible so you can try to request time off work and stuff like that. I realize this last one was a little bit short notice, but these are worth going to. And I think you'll learn a lot. And a lot of times when people visit campus and I talk to the parents of these students, I kind of say, college is what you make of it. You're only going to get so much out of the classroom, right? We're teaching to maybe not the lowest common denominator, but kind of the average student in the classroom. So if you're fine with being the average, well, then stick with the classroom and just roll with it. But if you really want to be challenged or you want, to kind of get a lot of information forced down your throat in a very short period of time and come out the other end exhausted, but more knowledgeable, I think these things are really worth doing. I don't know that you would talk to any student who's been to any of the hackathons we've ever gone to who said it was a waste of time. And we've had some that were 17-hour drives across the country that we've gone to, and I think most of them would do it again. So anyways, in a couple of weeks, we're going to Madison. This one's a student-only one. The one we just went to was student and professional, but it's almost always a majority students. But Mad Hack is in Madison. It's only an hour, 15 minutes away, something like that. And it's 24 hours long, and it's with students, and that one's much more of an organized experience. So you hack together some solution to something in 24 hours, and they feed you and all that stuff. It doesn't cost you a dime. Good experience. Take advantage of that. So check out the Mad Hack group here. Go ahead and join that and ask some questions. Check out the link for where I think the link is maybe in general. I don't know if you re-put it into Mad Hack, but strongly, strongly, strongly encourage you to take advantage of that. Okay. I was going to paste the code in here in 250, right? Okay, so let's introduce another method here that might be beneficial to us in maybe implementing a couple of these functions. So I'm going to go back into Keynote here. And we're going to introduce a method here called IndexOf. All right, so I'm going to actually give you the method header for it so we can kind of practice reading documentation. So if we were to go look this up at the documentation, IndexOf would return an int. It's called IndexOf, and it would take a char as a parameter. There's actually a second version of IndexUp, but let's just deal with this one for right now. The other one takes a string, so you can search for substrings, but let's just deal with this one. And this is a lowercase I. It's going to let me get away with that. All right, is this a class method or an instance method? This is the definition of it. Instance method, how do you know? No static. Okay, and I'm telling you this guy is defined within the string class. Okay, so this is an instance method of the string class. All right, now what this method does is it returns the position of the first occurrence. Nailed it. Autocorrect for the win. Returns the position of the first occurrence of C, that is the parameter we passed in the calling string, or -1 if it is not found. All right, so this allows us to search for something. So for example, if I had a string s is equal to hello, and I said s dot index of L, this would give me the position of the first L. So this is bucket 0, bucket 1, bucket 2. So the first L is at bucket 2, so this guy would return, in this particular case, the integer 2, even though there's another L at position 3. Okay, so IndexOf gives us the position within the string that was the first time we ran into that char. S.indexOf a z would give us a -1 because z is not found inside of the calling string. The calling string is s in this case, which is the string hello. Is that a legal line of code? Is that a legal line of code now? What do you think? How many of you think this is legal? If we put this in there, it would work. Okay.
Exactly like that?
Sure. 4.25 people? 4.5 people. Okay, 4.5 people. Okay, so I assume the rest of you think it will not work? Who thinks it will not work? It's crappy voter turnout. Now, you didn't vote for it to work, right? Which do you think? Who thinks it won't work? Or who suspects, strongly suspects even, that it won't work? All right, why do you think it might not work?
Well, partially because of the others, but...
Is it that this part just doesn't quite look right? That's like, it looks funky, right? Having a physical string there in the front. I mean, we're more comfortable when we have variables in the front, right? Though that looks better to us. So if we're comparing this line and this line, this guy S here is a variable, right? Where this guy, that's a string literal. I'm not necessarily saying we'd ever do this. You know, we would have to come up with a stretch for when that would make sense. Actually, it wouldn't have to really be a stretch, because I'll show you an example where it makes sense here in a few minutes. But the point is that this guy and this guy are the same. Variables always resolve to their value at runtime. So when I say s.index of z, at runtime, this s will turn into hello. It'll become that. It'll become the actual value of s at runtime. Does that make sense? Now they look the same, don't they? Or mostly the same, different words, but they mostly look the same. All right, so this will work down here. This guy is a string. Therefore, he is an instance of the string class. Therefore, he'd be allowed to call the instance methods defined in the string class. Go ahead.
All right, so kind of two things. Firstly, when declaring an instance of a class, is there any functional difference between using string s ended there or string s equals new string?
Okay, well, we don't know about the new keyword yet, and the short answer is yes.
Okay.
Let me get through this, so why don't you ask me that question again in about 10 minutes. So somebody remind him to ask me again, because it's a good topic to talk about. It's a topic we will talk about. I don't know if it's what was going to come next, but kind of just shoot from the hip when I see what kind of pops up. But it is a very good topic. The short answer to your question is yes, there is a difference, even though it might seem like there's not. And I'll give you a good reason why. Okay, so let's look at a use of IndexUp. So let's just go to our isVal guy here. We would say that this wasn't hard to write. It was like a little tedious to write, correct? So now what does it mean for something to be a val? It means that it's found in the set of things A, E, I, O, U, or capital A, E, I, or U. It's somewhere in that collection of chars. That means it's a val. Now, a hint here is that this guy, IndexOf, is actually a power tool for us. And I might argue that its greatest strength is on the the side you might not suspect. It's all fine and good finding the position of the first occurrence of some character. That's going to be handy sometimes, right? You know, that's kind of a nice go-to move. It's actually the -1 property of this that becomes very powerful, because it allows us to say, is something a member of this set? Does that make sense? So I know that C is a val if when I call IndexOf on the string representing all the vowels, it gives me something other than a -1. So if I replace all that with A, E, I, O, U, A, E, I, O, U, dot IndexOf C is not equal to -1, or you could say it's greater than -1, whatever makes you happy. So if whatever IndexOf on C returns something greater than -1 when searching for that guy in the string of vowels, that means it found it in there. It's one of those guys. It would only return a -1 if it couldn't find it. Does that make sense? So this Boolean expression right here, and this is a Boolean expression, is it not? What's a Boolean expression? Any expression that boils down to a single value of true or false. And this guy here on the left, this guy's going to give us a number. Guy on the right, this guy's a number. The greater than sign is what ultimately turns this into a Boolean expression. Make sense? So if the character I passed in here is found somewhere in A, E, I, O, and U, blah, 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 this function will give me a value that is greater than -1, something other than -1. Therefore, this Boolean expression will boil down to true. If it's not found, it'll give me a -1. Is -1 greater than -1? It's not. It'll boil down to false. So functionally, this gives me the exact same answer as the previous thing I had in there did. And we can go ahead and run this guy, and we see we get the same output. Make sense? So IndexOf, pretty powerful. Okay, let's go ahead and address your issue right now. Because this is actually going to be a pretty important thing, and that is comparing strings to each other. Okay, when we compare strings to each other. So I'm going to take out some of this extra code here, and we're going to say string s2 is equal to Let me go with hello because that's easier for me to type. All right, and we're going to go ahead and say Boolean answer is equal to S equal to S2. Now, this might look a little funny at a glance, but this is the assignment operator. This is the Boolean equivalence operator. So I'm saying, is this guy equal to this guy? Store the result inside of answer, which is going to be true or false. If it makes you feel better, you can always surround this by parentheses, and it kind of divides up those equal signs being a little too close to each other a little bit better, but whatever makes you happy. It works either way. All right, so we look at S and S2. We look at hello, and those guys are equal to each other, right? Cool. So if I were to then come down here and I were to print out answer, we would expect to see a true. Everybody agree with that? All right, so let's run it, and we see a true. There's our true. All right, so now, something that he mentioned, this new keyword. I'm going to show it to you initially. It's actually something you very rarely use with strings. And that's kind of why this problem doesn't actually pop up that often. But we use it. This is why strings are, I mentioned last class probably that Java is a string-based language. I've probably mentioned it several times. Okay, so if you can get something into the form of a string in Java, you can do pretty much anything you want with it. That's a very, I use the word malleable because it's fun to say, right? Malleable. Right? It's fun to say. Right? You have to agree with me on that. All right. So, in any case, it's something that we can work with. Well, because of that, Java has given me something called syntactic sugar. And so the reality is any other object in the Java language, we would create saying new string like that. This is the actual syntax for creating objects in Java. Every object that we write, and the next thing we're going to start working on is writing our own objects, but every object that we write in Java requires that new keyword. The one exception is the string class. Now, we talked about primitive types. What are primitive types again?
Basic types, variable types that are defined in Java.net.
And what's the most important aspect of a primitive type? Goes along with our quiz from last time. They can only hold a value. That's the extent of their talent. That's why that character class exists, is because we might want to do some stuff to chars that chars can't do to themselves. Okay? They don't have those abilities built in. All right, so now strings are object types. What evidence do we have of that? We've already seen two functions, two methods that they can do. So that immediately disqualifies them from the primitive type, correct? But if we were to pick one object in Java, it's kind of the closest to primitives. It would be the string because it's so important to the language. Because, as I keep referencing, Java is a string-based language. So because of that, they've given us this convenient syntax where we can define a string more simply like that. I usually call things like this syntactic sugar. Okay? That's a fun phrase to say too. Almost as fun as malleable. All right, well, maybe more fun actually. I might like syntactic sugar better. So now what ends up happening with a lot of Java programmers, this kind of falls into that same category of whether of even professional developers, depending on how they learn to program. And this becomes kind of my argument for whether you go and get a college degree and actually get a background in computer science versus go to one of these programming boot camps where you learn the skill of programming. The college, I mean, at the end of the day, you might be able to do all sorts of jobs with both of those. But the computer science theory explains all this information about memory and what's actually happening under the hood, that kind of stuff. And it's situations like these where it can be valuable. These two guys are not the same. I will get a false now. Okay? So let's go ahead and run this. There's my false. So clearly, even though I've said that every other object in Java we use the new keyword for creating an object, whatever that guy is. But for strings, since strings are basically primitive types in Java, they're so ingrained in the language, so integral to the language, that Java has given us the syntactic sugar for more conveniently creating strings. That's a true statement, but we've just proven to ourselves that it is not identical. There is some difference between these. Does that make sense? Ultimately, it comes down to this. It comes down to this operator right here. What's that operator? It's the equivalence operator. So this is the equivalence Boolean operator for primitive types. That operator allows us to compare primitive types. Now, if I were to, so let's introduce a new method for strings, just to throw it out there. So we have a method called equals. It returns a Boolean. I'll just roll with that. Returns a Boolean, takes a string as a parameter, does not have static out front, so this is an instance method. So this guy returns true if the calling string is identical in content as S, and false otherwise. There's also a second version of this guy called equals ignore case that does almost the same thing, except it ignores case sensitivity. So hello with a capital H would be the same as hello with a lowercase h. Make sense? If that's ever helpful to you. Notice this thing here called content. So if I come in here and I change this, I say s dot equals s2. So I use the equals method for these two guys, which is an instance method of the string class. So I'm saying s call your equals method and compare yourself to s2. This guy will now return a true. Because clearly we can see that the contents of S and the contents of S2 are the same. It doesn't take a rocket scientist to recognize that HELLO is the same as HELLO. You know, if I throw the capital H there, now it'll be false because I am comparing them with case sensitivity turned on. I'm not using the ignore case version of this. All right. So then the question comes down to, why is this version a false? This equivalence operator is the primitive equivalence operator. Now, first of all, are strings primitives? They're not. They're the object that's the closest to a primitive for us. That's why Sun and now Oracle, you know, the owners of the makers of the language, gave us this syntactic sugar for working with strings. Okay, but that came with some consequences, and it's also kind of, I think, from a teaching perspective, maybe kind of a bad thing because strings are the only object that behaves this way. Yet it's almost always the first object you teach in Java because strings are really important in a language. So we start off with a special case is kind of the problematic aspect of this. Now with that in mind, this guy is the primitive equivalence operator. It's for comparing things like ints, chars, floats, doubles, that kind of stuff. Yet it's not screaming at us here. Now, you've told me that strings are actually object types. We've seen it. They have a whole bunch of instance methods. And I've advertised to you accurately that primitive types can only hold a value. That's it. Why does this work when we're comparing strings?
the first line is the second, the S2 is not natural.
No, both of these are object types. Yeah, but that's actually not a bad guess. I mean, he was saying that because this uses alternate syntax, it actually created a primitive, is what you were suggesting, right? Yeah, but we saw that S actually has a method here. Yeah, definitely not a primitive. But I mean, that's not a ridiculous answer. That's a perfectly reasonable thing to at least ask. This guy only works for primitive types, and we have a kind of a hidden primitive type in Java called the pointer. And I know we've talked about pointers last semester, at least briefly. I'm going to throw it up here again. Anybody remember what a pointer is? Yeah. A primitive type capable of holding a memory address. Okay? Now, Java does not allow us to directly work with memory. This kind of goes back to that conversation we had about how Java, sort of the upgrade to C++, empowered the programmer to make poor decisions. I can hand you the house instead of the address of the house if I'm inviting you to the party, that type of thing. So C++ and its predecessor C gave you full control over memory. Now, as a programmer who maybe knows what they're doing, that can be powerful sometimes. It could also maybe let you write some code that technically works but isn't very easy to read because you can do a lot of memory manipulation, and it can get you into trouble sometimes, if not from a functional perspective, just from a job security perspective or playing well with other programmers perspective. But Java said, look, we could apply a pretty good filter on what makes sense and what doesn't. So what Java does is says, look, we're going to take control of memory away from you. We will make the decisions. We will decide when it makes sense for something to be sent in by value and when it makes sense for something to be sent in by address. Okay? So we can say in real life that it would never, ever, ever make sense if you're inviting somebody to a party to hand them a house and say, open the door at 8. That would never make sense, right? Java would say, look, I can make that call for you and not let the programmer run into trouble either through ignorance or just lack of thought or something like that. So we have this thing called the pointer. Now, the reason I don't like using a textbook in a Java class is almost all Java textbooks say that pointers don't exist in Java. That's not a true statement. The reality is that we lack a syntax for specifying pointers in Java. Pointers still exist. They're just shielded from us. Okay? And we actually have evidence sitting right in front of us right now with the difference between these two lines. This guy, we would call this guy a string literal. Okay, so we have this concept of these literals. Okay, so we have our numeric literals, so 0, 1, 2, ... 9, so on and so forth. So Java knows about our numbers, our base 10 numbers, 0 through 9, and then knows that you can have collections of those to build big numbers. It knows about the Unicode character set, right? Kind of already talked about that. It knows about our decimal type things, so we can use all those numbers things with a single decimal point to build kind of more complex numbers, let's say. But is there kind of an infinite number? It's not really actually infinite, it's not fair, but a gigantic number of unique strings that we could create using the Unicode character set. And what did we say? That the maximum size of a string, I think we looked up last time or 2 times ago, was about 2.1 billion. So we have 65,536 unique chars. And each character in a string can be any one of those guys. So it would be 2.1 billion to the 65,536th power. That's the number of unique strings. A lot. That's a lot of them. And each one of those, if we were to pre-store all those, like storing 0 through 9, we can swing that, right? That's fine. But if we were going to store, I don't even want to guess what the number is. An unpronounceable number. Well, unpronounceable by me. I'm sure, mathematicians, they have a name for that that final, whatever. But that would take up a lot of space, more memory than our computers have, right? So we're not going to store every single possible string that you might ever create out of the Unicode character set. That would be ridiculous. Especially when we consider that in our programs, we only need access to the strings that we've created, correct? It's reasonable for us to store the 0 through 9 because we're going to use those numbers all over the place, and it's not that big. So what ends up happening is when we store a string like this, when we use this syntax for creating a string literal, what it's doing is it's saying for strings, we have this literal table. It's right with the numbers. So we have the number literals, we have the char literals for all the Unicode characters. Then we have this kind of area down here, a bucket, for holding string literals. So right here, when I created S, I created a string literal in here for hello. Now if I say string S3 equals hello, and we've seen that S and S3, these guys would be true. So there's the true on that guy. What ended up happening here? When I created my literal here, we checked that literal table and said, is there already a hello in there? There's not. We'll go ahead and create one. Now this has a memory address. Okay, we put it in memory, we put it right here. Okay. Is this guy, did he already exist? He didn't, so I put him there. And now he has a memory address. Now when I go and create S3, creating hello again, I'm checking in this area here, do I already have a literal in here named hello? I do. It would be wasteful for me to create another one, right? So instead, I'm just going to give S3 the same memory address as the literal I already have here. So when I say S equivalent to S3 right here, I'm actually comparing the memory addresses. S and S3 do actually live at the exact same place. That make sense? Now, we saw that S2, though, if I try to compare S or S3 to S2, I get a false. Even though we look at S2 and we see that this guy, well, it's still hello, because I'm using the new keyword here, I'm not dealing with the literal table. New says create new memory. We are specifying that we want new memory. I don't care if we've already stored the literal hello. I want a new bucket for my hello. That make sense? So even though hello's right here, I'm going to create a new memory location up here to hold S2. So S1 and S3 both point to this guy. S2 points to this guy. Now if I compare the memory address of this guy to the memory address of this guy, are they different memory addresses? We would suppose so because my hands are in different places, but they are. These are different memory addresses, which is why this fails. Because the double equal sign is comparing the memory addresses, the location of those two guys, because that guy compares primitive types. If I want to compare the contents of those strings, I would say dot equals. Actually, let me switch it to this just so I can ask another question here. So what's the difference between this line? I'll take out the extra set of parentheses just so they look very close to each other. What's the difference between this and this? they will always have the exact same result. My question is why? What's the difference between those two lines? Go ahead.
The difference is the object that's calling the method.
Yeah. We've talked about the equals method and decided this guy does not have static in front of it, right? So the equals method is a method that lives within a string class that is an instance method. Therefore, it's called with an instance of the string class. In this case, it is S who is calling his version of the equals method and comparing himself to S2. In this case down here, it's S2 who's calling his version of the equals method and comparing himself to S. Does that make sense? So they're going to have the same result because S's equals method knows everything there is to know about S, and we're providing him the information about S2. S2's equals method already knows everything there is to know about S2, and we're providing him with the information about S. We're going to get the same result, but these are actually different versions of the equals method belonging to the different owners, S or S2, depending on who's calling his instance of that method. That makes some sense? So if we want to compare the contents of a string, we use equals. If we want to compare the memory address of an object, whether it's a string or any other object, we use the double equal sign. Make sense? Okay. And it's actually a really good question that you asked that because it's pretty common for programmers, especially programmers who come from some other languages, for them to use the double equal sign in Java for comparing strings. For instance, in C#, you can use the double equal sign for comparing strings, and it will treat the double equal sign as the equivalent, as the equals method if you have strings on both sides. It does what we would expect it to do. Because realistically speaking, as much as strings are part of the Java language, as it's a very integral part of it, not that often are we really going to run into a situation where comparing the memory address of strings is a handy skill. We might care about memory addresses of things other than strings, but strings they're just a kind of a different tool, a different level of object, even though technically they are objects. Does that make sense? So in C#, they made the decision that says, look, it doesn't really make sense to compare the memory address of strings. You can actually still pull it off in C# because C# allows you to create an unsafe code block and then use the special syntax for pointers. So you can still do it if you really, really, really wanted to. But 99% of the time, let's say, if you want to compare two strings, it would be nice just to use the double equal sign. That would be a convenient little thing rather than have to do the whole dot equals thing. C# allows us to do that. Java does not. And if you look at the lineage of those languages, C# came out after Java. Make some sense? So they kind of made that decision. So, like I was saying, very good question because this is one of those things that does impact programmers coming from different languages. In general, I make that comment that all programming languages are the same. You're learning programming as a skill set. Moving to a different language is not a big deal. And in general, that is a true statement. But every now and then you'll run into a little caveat like that that can really haunt you until you figure out that piece. Okay, so that's our equals method. Now, what we might want to do here is we might want to create our own object and kind of move these guys into our own object. So I'm going to start talking about objects here. Actually, before I forget, why don't I go ahead and write out what our next assignment will be. Since I already put this code up, let me just get rid of this. Call this binary 2 decimal. And we'll this decimal to binary. Binary to decimal takes a string representation of a binary number and converts it to decimal, returning the answer. Kick that down a line here. Decimal to binary takes an int and returns the string representation of the binary equivalent of that decimal number. All right, so this is taking that skill set. So, for example, binary to decimal. If you took in the string 1001, this guy would return, this is the ones place, 2s, 4s, 8s, so this would return a 9. The decimal equivalent of 1001 is 9. Similarly, this guy, if it took in a 9, he would return 1001. If he took in a 10, he would return 1010. That's 10. Make sense? So this will give you some practice of converting numbers again, like I like to ask you to do. And at the same time, it will also give you practice taking a problem that you can solve in real life and turning it into an algorithm. All right, and then what we're actually going to do in class next time is we'll convert these into base to decimal and decimal to base. That allows us to convert to the other guys. That makes some sense? All right, so that'll be our assignment for Thursday. Let's just go ahead and get started with creating our own class. So we've mentioned previously that all programs begin and end with main. Now, I also mentioned that I call this class driver because it's kind of the guy that drives this program. Now, as our programs get more complex, we may write more than one class to represent stuff for ourselves. So I'm going to go into this project here. And I'm going to right click and I'm going to create a new class. And we're going to call this guy string helper. Actually, since we already deleted those methods, let's just call it something else. Let's call it dice. I think we wrote something like this last semester, right, in Python. So we'll see the equivalent of that in Java. So we're going to call this guy dice. We want to represent a dice. Okay. And just for the time being, since we're a little short on time here, let's do something quick. We're going to create a variable in here called sides. Now, we could actually stop right here. And this is a functional class. It was actually a functional class without anything in there, but now it's at least useful. All right, so I created an integer called sides in here. Now notice that this class does not have main in it. I can now come out to driver. And I can say dice d.sides is equal to 5. Now notice that this guy is screaming at me. It's going to say d does not have a value. The local variable d may not have been initialized. I created a variable named d of type dice, but I didn't give it a value. The values that live in our objects is the memory address of the object. Like I mentioned earlier, we always use the new keyword to create an object. This is our constructor, which I will talk about a lot more next time. But if we do not write a constructor inside of our class, a no argument constructor that does nothing is provided for us, right? That supports this syntax. This says, give me some new memory big enough to hold one of these guys. And go ahead and build that object with this guy. In this version, it says do nothing. So now I have a physical memory address to store the stuff related to dice. And in that memory address, I now have access to a variable called sides. And I can go ahead and set sides equal to 5. And then I can do something like system.out.println d.sides, and that'll print out my 5. Okay? Now, what we've effectively done there, we go back to dice and we think to some of our older languages, we've effectively mimicked structs from C and C++. But there's one difference, and that is, and I'll just mention it now, I'm sure it'll pop back up again later. But the difference is that in C and C++, if I pass a struct to a function, it's passed by value by default. So if I change it inside that function, it is not permanently changed. In this case, it's an object. Even though it looks like a struct and mostly acts like a struct, if I pass this to another function and I change it, it will permanently change. Let me go ahead and I'll just put a comment in here. Show pass by value stuff. And then I'll force an error in there. So it won't run until I fix it. That'll remind me for next time. All right, questions, comments, concerns, bribes. All right, I will see everybody on Thursday. And I'll go ahead and put this homework assignment up. Just copy these comments in there. Today, faculty, student, staff Bible study, God and Grub. Just go down to the cafeteria, sign in, you get a free lunch, grab a tray, get your food, blah, blah, blah. Take it down to the terrace room.
Okay.
That's from noon to 1. Yeah.
I go ahead and upload my thing. It didn't upload.
Okay.
I just uploaded it. You'll know that it wasn't copied all off of the.
Okay, it's your own implementation.
Yeah,
all right.
You'll know because I couldn't access the video.